let's revise. Let's make sure that we know what's happening. I just want to change my order because I'm make choices that aren't always the best choices. So what we've got here, guys, are a list of numbers. This is very similar to an example we did when we spoke about the number system earlier on. I'm pretty sure it was in our first lesson. And so what we want to do here is we want to take this list of numbers and we want to identify specific numbers according to the questions or the instructions. So remember, I've said to you as well, whenever you get given a list of numbers like this, make sure that the numbers you've simplified, just so that you know exactly what you're working with. So 3 squared we know is 27. 30 is obviously 30, so we keep going. 2 over 5 is just a fraction. Square root 3 gives us a whole long decimal, and then we've got 1,3 and 3 pi. So if you can simplify values or numbers, do that so that we know what numbers we have in our list. So if we have a look at our first question, it is asking us for an integer with factors of 2 and 5. Now let's forget for a second the whole factor thing. Can someone raise their hand and tell me what is an integer? So what is an integer? You can put it in the chat if you want. Nosisa, what is an integer?
It's whole numbers. It's natural numbers and whole numbers.
Okay, yes, I definitely agree with you. Is it only the positive values?
No.
It's also the negatives. Excellent. So guys, remember, integers are basically all of your positive and negative whole numbers. So just basically no fractions. If we think about our integers here, 27 is an integer, 30 is an integer, and -3 is an integer. Those are all of our positive or negative whole numbers. And so now we need to decide here which one of those, 27, 30, or -3, has factors of 2 and 5. Now remember, factors are numbers that divide into the number we're working with without a remainder. So Leto, do you want to tell me what the answer would be here? Seeing some good answers coming in on the chat. Well done, guys. Leto, you there? Okay. Ukukle, you want to try this one?
Yes, ma'am. Oh, ma'am, it's
Okay.
30.
Excellent. So 30 is our number here. We know that the factors of 30 are 1, 2, 3, 5, 6. Why am I panicking? 10, 15, and 30. And so 2 and 5 are factors of that number that we were working with. So because 2 and 5 are factors of 30, which was in our list, we can say that 30 was the answer we were looking for there. Alrighty, Okokle, and okay, so Jill, do you have a question? We can hear you. Do you have a question?
No, ma'am, it's fine. I wanted to find out. I was about to say the answer, ma'am.
For A.
Yes, ma'am.
And do you agree with 30?
Yes, ma'am, I agree with 30.
Excellent, well done. Alrighty, guys, very nice. So let's have a look at B. So B says rational numbers that are not integers. So can someone remind me, what are rational numbers? Jill's on it. Jill, what are rational numbers? Or did you not want your hand up? Okay, Bokang, what is a rational number?
Hi, ma'am. A rational number are numbers that can be expressed as a fraction that are recurring and terminating.
Perfect. So basically, guys, as long as you can write the number as a fraction, that says written, sorry, then you have got a rational number. Now, as Bokang said there, we can add to that definition in that it's decimals that end, so it has a stopping point, or decimals that repeat or are recurring. So as long as you've got those in place, you've got a rational number. And so what it's asking for here is a rational number, so a number that can be written as a fraction, but a rational number that is not an integer. So we don't want any positive or negative whole numbers, because that's what we said an integer was. So Mpumelelo, do you want to try this one for us? Oh, golly.
Ma'am,
Yeah. What?
that are not integers, it's -3. The square, I think it's a square, or 1,3,
Okay.
and I think it's a square root, or yeah, the square, the one next to the fraction, and the 30.
Okay. So, all right, good. So, okay, so guys, what we need to be careful of here is we want rational numbers that are not integers. Now, the 3 cubed, the 30, and the -3 are integers. Remember, we circled that for the first one. So we can't consider any of those. We only want the ones that we can write as a fraction from the remaining 4. Now, obviously, 2/5 is a fraction. It's written as a fraction. So that is a rational number. And 1,3, although not written as a fraction, I could write as a fraction, 13/10. Now, the square root of 3, remember I said is going to give you a whole long random decimal. So we can't write that as a fraction. And we know pi is quite special. So in this case for B, our answers here are 1,3, as Mpumelelo said, and 2/5. Okay, so just be careful. We're reading our questions very carefully as we go along. Amatli and Kiketso, your hands are up. So if they are up for questions, you can leave them up. Otherwise, please lower them. Oh, thank you. You guys are on it tonight. Right, so question C says an integer, but not a whole number. So hands up, who can tell me what a whole number is? Koena? Hope I'm saying your name correctly. Okay. Guys, remember when I call on your name, 5 seconds to unmute and then I move on. Tato, what is a whole number?
Ma'am, a whole number consists of the natural numbers and 0.
Excellent. And what are natural numbers?
Natural numbers are counting numbers.
Excellent. So essentially our counting numbers are the numbers that we think of when we learn to count. So, oh wait, sorry. 1, 2, 3, 4, and so on. But as Tato said, we also include 0 and whole numbers. Now we know what integers are. We've written the definition down there. We now know what whole numbers are. So in this list of numbers, which number is an integer, but not a whole number? Riobetswe, do you want to try this one for us?
No, it's okay, ma'am.
Okay. Kiketso, do you want to try this one for us? Sorry, guys.
Ma'am, C is -3.
Excellent, well done. So guys, remember, these were all integers. If we think about the definition we just got for whole numbers, 27 and 30 are counting numbers. It is then only -3 that is not a whole number. So exactly as Kaketsu said, -3 is an integer, but not a whole number. I'm just going to take all of these scribbles off so we're not getting confused. Right, Mpumelelo and Tato, your hands are still up. So if they're up for a question, you can leave them up. Otherwise, lower them. Good, well done. Right, guys, let's have a look at D. So I want you to listen carefully. I want you to think carefully. D is asking for a natural number smaller than 10. Now, Tato has already told us what a natural number is. So hopefully we were all listening. A smaller number, oh yes, a natural number smaller than 10. So take a second, have a think. I already see some hands, which is awesome, and I'm going to give everyone a chance to think about it. I hope I say your name correctly. Wutahawe?
Hi, ma'am. The answer for D, it's 3, ma'am. Yes, ma'am.
But we don't
the
have a 3 in our list.
It's 3N, ma'am. I meant to say
It's
sorry, ma'am.
So you meant to say 3?
3N.
This one here.
Yes, ma'am.
Okay, so that's sorry, that's a pi. So not an N. And remember, pi is not a national. Pi is not a natural number. Natural numbers, guys, remember, Tato told us are counting numbers. So it's only the whole numbers 1, 2, 3, 4, 5, 6, etc., etc. So do we have any of those that are smaller than 10 in our list there? So think carefully. Lolita, what do you think? Okay. Tulu, do we have any?
Ma'am, I said 3 to the power of 3 because 3 to the power of 3 equals 9.
Equals 27.
Oh, my bad, sorry.
If it had been 3 to the power of 2, I completely agree with you. And that is why it's so important that we work exponents out. Okay, so very nicely done on pointing that out for us. Thank you. TK, you want to help me out? Oh yeah, I'm just unmuting people. There we go. TK, okay, there you go.
Yes, ma'am. I think it's -3.
Okay, so remember, -3 is not part of our natural numbers, and we want it to be natural.
Yes, ma'am.
Theo, what do you think?
Ma'am, I think it's 1,3.
So remember, 1,3, not a natural number. We don't have any decimals in natural numbers.
Ma'am.
Okay, Oratile, what do you think?
Ma'am, it's none of the numbers.
It's none of our numbers. We don't have a single number here that is smaller than 10, which is a natural number. We have numbers smaller than 10, but none of them are natural numbers. And so this was a bit of a tricky one because we had to be very careful in actually knowing what a natural number is. Very, very nicely done. Good, guys, well done. Right, last one, an irrational number. So who wants to tell me what an irrational number is? Hands up. Callan, what's an irrational number? There should be a pop-up to unmute. Oh, there we go.
Irrational number is a non-terminating
Callan, your sound's a bit funny. Just, can you try again?
sorry, ma'am. It's a non-terminating,
Yeah.
non-terminating non-recurring decimal cannot be written in a fraction.
Excellent, well done. So guys, irrational numbers are non-terminating, so basically it means they never end, and non-recurring, which means there's no pattern to the decimal. And so what that essentially means is you can't write them as a fraction. Can't with an apostrophe. So if we look at our list of numbers, hands up, which ones do we think are irrational numbers? Take a think, take your time, there's no rush. Think carefully. Lena Mandla, which ones do you think are irrational?
I think it's 3 pi.
Okay, excellent. 3 pi is definitely one of them. Tammy, do you have any others for us?
Yes, ma'am. Also the square root of 3.
Excellent. So guys, remember I said to you square root of 3 is going to give us a whole long random decimal. So square root of 3 is 1,7 32050808, and that just keeps going. There's no pattern to it, it doesn't end, and so I can't write it as a fraction, which means it is irrational. Very nicely done, guys. I'm going to wait there for a second in case you want to take a screenshot. Everyone with hands up, please lower them unless you have a question. Right, Manindle, do you have a question?
Yes, ma'am.
Yes.
So, ma'am, for the rational number, since it's never ending, can you also call it an infinite?
Yeah, you can.
Thank you, ma'am.
That's perfect. Good. Right, guys, I'm hoping we've got our screenshots. Three, two, one. Right. So you're going to try 2 for me, and then we're going to take a little break because you guys have done really well tonight on it, asking really good questions, giving me awesome answers. So I want you to try simplify these 2 expressions for me. I'm not going to say anything. I want you to try. If you get stuck, that is fine. Either ask on the chat or let us know that you have a question, and then you can raise your hand. But I want you to try simplify A and B for me. Remember your order of operations. So the only thing I will write here for you is remember bedmas, or you can say bodmas, doesn't really matter. Remember your order of work or your order of operations. That's very important. Otherwise, we're going to get weird answers. All right, I'm seeing lots of hands, seeing lots of answers, and thank you so much everyone for putting A and B. Makes life so much easier, and I didn't have to tell you, so well done. Right, Emmanuel, do you want to give us A?
Yes, ma'am.
Okay.
Ma'am, so I said 17 plus -9, giving me 8.
Okay, now what happens when I've got the plus minus situation there? What does that actually mean?
Ma'am, a positive plus a negative gives us a negative every time, ma'am.
Okay, so good, guys. When we've got a positive times a negative, we're always going to end up with a negative. So as Emmanuel said, what we actually have here is 17 minus 9, and 17 minus 9 is 8. Now, just so that we all understand why I'm saying a positive times a negative. Oh, golly. There is technically an imaginary or a ghost 1 in front of that bracket. And now remember, between a number and a bracket, there is a times. So what we actually have one here, rather, is positive 1 times negative 9. And that's why I'm saying a positive times a negative is a negative. We need to remember that whenever we have a plus and a minus right next to each other, we have got, we are working with, rather, a negative. Okay, very nicely done. Papedi, do you want to try B for us?
Yeah, bo, man.
Okay, ready.
Oh, yeah, ma'am. The answer is, I mean, like, I did it step by step. It's gonna say negative 39 plus 3 equals to negative 36. That's my answer. ma'am.
Perfect. Excellent. Well done. And I like that statement, guys, of do it step by step. If you're not 100% sure, because it's all positive or because it's all addition and subtraction, you just work left to right. So negative 24 minus 15 is negative 39. And then only do we do the plus 3. There's no, you don't have to. There's no like requirement that you do it all in one go. Do it step by step if you need to. All right, but importantly, there was the negative. We needed to have a negative 36 there. Right, I'm just going to wait here in case you want to take a screenshot. We will come back to these questions, but we're going to take a little break now. Excuse me. So if you don't get a screenshot, don't stress. I'm going to come back. But I'm just waiting in case you want to grab one quickly. Doing really well, grade 9s. You're on it. Right, Nsako and Butahawe, your hands are still up. Manentli, you are more than welcome to go drink some water. Don't you stress at all. You can drink while I talk, I don't mind. We're going to do a brain break, so there'll be a chance for you to quickly grab some water if you need. I'm going to have to grab some water as well. My throat is like a little scratchy thing going on here. Okay, right, brain break. I thought the koalas and the frogs and the foxes were cute. Okay. Hope, I'm not too sure what you are correcting me on. Bedmas, yes, brackets. I'm not too sure what I said that has maybe confused some. Oh, okay. Hope, you can use bedmas. So not wrong, just different. Bedmas, the E stands for exponents. If you're going to use bodmas, that's fine. Order means exponents as well. I just prefer E because exponent is clearer for me. But it's absolutely fine. You can use bodmas. It means the same thing. I just find that exponent is a lot clearer, but that's my personal preference. Okay, right, guys, don't worry. We'll come back for you to screenshot, so don't stress. I'm going to see how many of you get the joke. Let's see how many of you listened in the first lesson if you were with us. Whilst you're having a look at that, here's your brain break. We've got cute little koalas, frogs, and foxes. You know the drill. I think let's try today. Some of you will already know this procedure. I am not going to take any hands. I'm not going to do anything. First person to put the correct answer in the chat, I'm going to call on you and you're going to explain to us how to do it. So you can do what's happening here. You can help each other. If you want to help each other and you feel like you're going to be nice people, you can help in the chat. But I'm going to wait for the correct answer. And the first person who gives me the right answer, I will call on. So I'm not going to say anything. I'm even going to mute myself so I don't have this urge to talk. See, and then I started talking. When I say the answer I mean is this answer, the question mark answer. Okay, so I want the final answer. I'm going to wait for everyone to get there. I like that we're helping each other. That's what this is all about. Emmanuel, if that hand is up to give me a final answer, I want to, Mpo, well done. Very, very nice. On it. So Mpo, if you want to raise your hand and explain to us, I would love to hear your explanation. You were the first person to get it right. So Natemba, Tami, Melo, Bokumaso, well done, guys. You're all getting it. Excellent. Okay, so all of those people, I don't know. Mpo, do you want to raise your hand? I'll give you another second or two, otherwise I'll ask someone else. You don't have to, no pressure. Okay, would anyone like to raise their hand to give me or to explain how they worked out the answer? Excuse me. All right, Tammy, tell me, how did you do it?
Okay, ma'am. So for the first one, I divided 27 by 2, which gave me 9. And then
maybe yeah.
For 306, I said 306, and then I wait, how did I get this? Oh, okay. So for 306, I said 306 minus 18.
And then why did you say 18?
Oh, ma'am, because I said, because ma'am, there are two pairs. Yes, ma'am, there are 2 pairs. So if you multiply 9 times 2 gives you 18.
Excellent, well done. So guys, there's 2 koala bears, which means that we've got 18. Okay, keep going. So you subtracted 18 from 306.
Yes, ma'am, which gave me 288. And then I said 288. I divided it by 18.
Excellent.
The answer I got was 16. So it means that
excellent.
1 for. And then for the fox, I said 116 minus 16, which gave me 100, and I divided 100 by 2, which means 2 foxes are equal to 10. And then for the last one, I said 10 plus 8. The reason why I say 8 is because there's 1 fox, so you divide 16 by 2, which gives you 8. And then I multiplied it. Oh, and then I multiplied it by 9, which gave me 82.
Okay, so now which operation do we do first in the last equation? Do we do the times first or do we do the plus first?
The multiplication.
Good. So guys, multiplication first. 8 times 9 is 72. And then exactly 72 plus 10 is 82. Well done. Yes. That was a beautiful explanation as well. Excellent. So guys, we'll probably do some more competition type things as we go along. So Paul was our reigning ruler there because he's got it first, but Tommy is our star explainer. I don't know if that's a word, where I'm gonna go with it. So let's see next week. I don't know, I make up so many words in my daily life. I should make my own dictionary. Well done. And you got that very quickly. And so hopefully next week someone new, someone faster. Good explanations. Really nicely done, grade 9s. Did we all get the joke? I hope so. I thought it was quite a good one. Alrighty. Excuse me. Right, let us, I also think it's a useful skill. I make up so much stuff. My kids look at me all the time as if I'm going crazy, but it's fun.
I think to answer Hope's question, on next week Tuesday, we're doing exponents.
Yeah, so we will start exponents before the 7th, so don't stress. For the joke, yes, no, see, making up stuff, right. Hope. You guys make me laugh, honestly. Teaching is so stressful sometimes, and you make me want to bash my head against the desk, but you guys are just fantastic. Okay, so the joke, I don't know if you remember from our first lesson, but I spoke about the fact that we've got real and non-real numbers. So there's 2 number systems that we work with, real and non-real. Now, you guys will usually 99% of the time work with real numbers, but there are such numbers as non-real. Now, if you've got a calculator in front of you, what you can quickly do is you can type into your calculator the square root of -1. Now, those of you that are comfortable with surds and exponents, you will already know that this is not possible to get. And so your calculator gives you math error. Now, what that means is you're working with a number that is not in the real number system. Your calculator can't give you a value. And so this square root of 1 is actually a very famous non-real number. It's I. We use I to represent it, just like we use pi to represent 3,141526 blah blah blah. We use I to represent the square root of -1. And so this is why pi is telling him to get real, because he is currently non-real. And this is why the I is telling pi to be rational, because remember, we've just said that pi is an irrational number. We can't write it as a fraction. So, math joke. I hope we all get it now. Emmanuel, thank you. See, this is why I love you guys, like the sass, but it's great. Okay, guys, let's do this. Right, we have done A and B. Lolita, I also think I need my own math stroke page, if I'm being completely honest with you, but you know, I just sometimes I don't know if I'm that funny, but I'm gonna see. Okay, right. What am I saying? Okay. You have done A and B. If you did not get a screenshot, take it now, and then I'm going to move to C, D, and E that you're going to try. My brain has clearly just stopped working today. It's wild. After my whole, I don't even know if he told you the guys this. After my whole, I had a matric question that I was trying to do, and for the life of me, could not figure out why it was not giving me the answer. And my mistake was a sign. I got the wrong sign. That was it. I made my boyfriend look at it. I phoned one of the other teachers at Watobe, and I was like, I don't understand what I'm doing wrong. It was a stupid sign. And now I feel like my brain's just left me.
Oh, the little thing.
Well, this is the thing. And I just had a conversation with my matrix there. Like, I sat them down and I was like, guys, you need to avoid silly mistakes. Where you will go wrong is you will make a mistake with the sign. And then I made a mistake with the sign. Yeah. Anyways, right. That's my ramble and my rant done. You have got C, D, and E that I would like you to try. Go. KB, we will do geometry, not just yet, but we will eventually get to geometry. Guys, while you're answering C, D, and E, when you put your answers in the chat, please just remember to say C, D, and E, so that we know which answers are which, so that as we're seeing answers coming through, we know that you're getting it right or wrong or whatever the case is. I already see some hands. Very well done. Manently, I find it very exciting, if I'm honest. Sometimes it's a bit boring, but you always have a new group of kids. They're always different to the last group, and so you always do things a bit differently. So it's always a bit new in some way. Right, I see answers for C. I see answers for D. Very well done. Please remember your signs. Don't pull the teacher Sam and make a mistake with the sign. Remember BODMAS, remember your order of work, very important. Yeah, sorry guys, told you, my brain stopped working. Don't you stress. I was just reminding you about signs and BODMAS and all of those fun things that we already know. Okay, I'm clearly in a mood. I've got like a sudden rush of energy. Melissa, would you like to do question C for us?
Yes, ma'am. So
Okay.
with the negative outside the bracket and the 10 cancel each other out and become positive 10.
Cool. Okay, so just remember what we want to start with is the stuff inside the bracket. Do you agree? Because brackets first.
Okay.
Okay, so what is minus 10 plus 5?
Negative 5.
Oh, no. Oh, there we go. Okay, perfect. Now you can deal with that sign situation.
So you'd say negative 3 plus 5.
Cool.
Minus 4. And then it would be 8 minus 4, and your answer is 4.
Perfect, well done. So again, do it in stages or in steps if you need to. Excuse me. 3 plus 5 gives us that 8, and then 8 minus 4 is 4. Excellent, Palesa, well done, thank you very much. So sorry, guys. Trying to pick some people that we haven't had yet. Let me just go through some names. Spiwe, would you like to do D for us?
Yes, ma'am, and good morning. Good evening. As we know, a positive divided by a negative gives us a negative. So I
Very
said
well done.
56 divided by a negative 7, then it gave me a negative 8.
Excellent, well done. So guys, what was really important there was Sapiwa's first statement of the fact that when we have got a positive divided by a negative, we get a negative. Remember, the same rules apply for multiplication and division in terms of signs, and we need to remember that. And so here, what was very important, excuse me, is that we remember our signs. Theo, thank you. I've seen people telling me that this was in fact negative 3. See, the sign is my downfall, clearly. So negative 3 plus 5 is 2. 2 minus 4 is negative 2. Thank you, everyone, for being on it. Clearly, signs and me today are not friends. Maybe we'll be friends tomorrow. We'll see what happens. It's unlikely, but maybe the signs will choose to be my friends. Okay, so Correction for C, it was a -3 at the start. I do apologize for that. KB, in terms of showing your calculations, I would only show your calculations if the instructions say that you need to do these questions without a calculator. If it doesn't say anything like that, then the straight answer is fine. But if it says without a calculator, we expect you to show your working out. So just check the instructions and go from there. Right, I will come back to these guys so you can take a screenshot, don't stress. Let's have a look at the last one, E here. Whoops, so sorry, I'm just all over the place. Okutle, would you like to do E for us?
Yes, ma'am. E is 10 because I said 7 times -2, it was for -14, and I said 24 plus -14, it came out 10.
Perfect, well done. So guys, remember, multiplication first, we get -14, and so 24 minus 14, exactly, +10. Very nicely done, guys. Right, so if you want to take your screenshots, let's do that, so that if you missed A and B, you can get your screenshots there as well. And then all I want to do just before we finish off is just have a quick discussion about one example with fractions, and then we'll go from there. Kanya, where did I write -24? Am I just losing my mind? This is a +24. Theo, so today's quiz day, but obviously if you've got feedback about the page, you're welcome to send it to me as a message or to Nelisa as a message. We'll always take feedback. Takano, currently there's no app through Watobe where you can practice. You can access all of the past quizzes to practice them. In terms of practice though, if you just Google, there's so many places where you can find revision, whether it's worksheets or websites and stuff. Okay, Lolita, how do we cancel out the negative signs in question C? Okay, so we're not really canceling them out. I'm just gonna zoom in here. What we're doing is we're saying that, again, there's this ghost 1 in front of this bracket. And so what is actually happening here, let's put the ghost 1 there. What's actually happening is we've got -1 times -5. Now we know that a negative times a negative is a positive. And so that's why my sign became positive. And so it's not just like disappearing. There is a reason for it. It's essentially because the multiplication of 2 negatives gives us a positive. Alrighty. Right. I'm hoping we're going to have time to chat about this, but let's just see how we go. You can ignore A. What I just want to chat about is B, because hopefully it covers everything I want to say. I'm going to do it. Obviously, you guys, if you want to give it a go by yourselves while I'm chatting, go for it. But what I want to say here, guys, is remember that when we add or subtract fractions, you always need to have an LCD. And that is only when you add or subtract. When you multiply or divide, you do not need an LCD. It's only when you're adding or subtracting. Now, when we've got a situation where we've got mixed numbers, what we want to do is we want to convert those mixed numbers. We don't want to work with this format. You can, but my opinion, it's a little bit harder. So if we want to convert, remember we take the denominator, times it by the whole number, and then add the numerator. So 5 times 2 is 10. 10 plus 3 is 13. So this is 13 over 5 plus, and we do the same thing here, 1 times 3 is 3 plus 1 is 4. So 4 over 3. Now this is where the need for a common denominator comes in. We want the same denominator so that we can add the fractions. Now this is where you need to think about what number both 5 and 3 can divide into. Ideally, we want the smallest number. This is very similar to your LCM, your lowest common multiple. We just call it an LCD because now we're working with fractions. And so here, Emmanuel's already put on the chat there, our LCD here is 15. 15 is the smallest number that both 5 and 3 can divide into. Now I want to make both of those fractions have a denominator of 15. So I know if I times 5 by 3, I'll get 15. But what I do to the bottom, I must do to the top. And if I times 3 by 5 in my second fraction, my denominator will be 15. But again, what I do to the bottom, I must do to the top. 13 times 3 is 39, so 39 over 15, plus 4 times 5 is 20 over 15. Now, because we've got the same denominator, we can write this as one fraction. And so all I actually need to do is add together my numerators. It's just fix that weird looking 3 there. And so 39 plus 20 is 59 over 15. Now, guys, you always want to check if you can simplify. If you want like a quick way to do that, type it in on your calculator. So 59 divided by 15 on your, I can't see my face, so that's completely useless to me. If you type it in on your calculator and you push equals, your calculator automatically always gives you the simplified answer. So because it gave me back 59 over 15, I know that this is my lowest common, this is my most simplified form of the answer. So this was another conversation we had, fractions, throughout this course. And so what I just wanted to make very clear here is the fact that when you add or subtract fractions, you need to have an LCD. And that sometimes working with a mixed number, whilst not wrong, does complicate things. And so we can convert before we find our LCD and then go and add or subtract our fractions. Right, so LCD again stands for lowest common denominator. And that is important when we add or subtract. Hope, I see your question. So you've got -4 times -7 over 100 plus 25. Basically, what we do in a situation like that is we simplify the top. So -4 times -7 is positive 28. We simplify the bottom, 125, and then we check if that fraction can simplify. Just like I've said over here, always check if your fraction can simplify. Right, Chongwe, do you have a question? Chongwe? Any question? There we go.
Hi, ma'am. No, what I wanted to ask is already answered. Sorry, ma'am. So it's okay.
Perfect. Cool. Oh, sorry, I've asked you to unmute again. You can just ignore me. Angeline, question? Angeline, you there? Okay. Amukela, question?
Ma'am, how do we get the 3 and the 5 at the bottom? I'm confused.
Okay, so those 3 and 5s, and if you guys are confused, we're talking about these ones over here. They are coming from me needing to make the denominators the LCD. So I have to make 5 15, and the only way for me to do that is to times 5 by 3. But if I'm going to change the denominator and times it by 3, I need to do the same thing to the numerator. So those 3 and that 3 and this 5 is coming from me needing to make my denominators the same. I hope that makes sense. Papedi, question?
Yes, ma'am. Can you please like take to letter A, ma'am? I didn't see the full thing.
We didn't do A.
Oh, okay, sorry.
I left it out.